Hello everyone, the topic of this lecture is Construction Engineering Economics, Economic Evaluation of Mutually Exclusive Schemes with Equal Lifespans. The content will mainly cover the following two aspects. Overview of mutually exclusive schemes. Economic evaluation methods. For mutually exclusive schemes with equal lifespans. Overview of mutually exclusive schemes. Mutually exclusive schemes, also known as exclusive schemes, refer to a situation where among several alternative technical solutions, each can replace the others. Therefore, these technical solutions are exclusive. Choosing any one of them means excluding the others. In other words, during the comparison and selection process, only one option can be chosen from the various proposals, and the rest must be abandoned, as they cannot coexist. The evaluation of their economic effectiveness is not additive. This type of scheme is the most common in practical work. Examples include development plans for a piece of land, such as building villas, multi-story buildings, or high-rise buildings, where only one option can be chosen, or selecting the factory scale, production process flow, main equipment, and factory site for a construction scheme, as well as determining the structural type of a building or structure, or the construction technology. For the main structure of a scheme, decision-making for these types of issues often involves choosing between mutually exclusive schemes. The comparison and selection of mutually exclusive schemes is a crucial part of engineering economic evaluation, and a necessary means to seek reasonable decisions. The economic evaluation of mutually exclusive schemes consists of two parts. First, examining whether the economic effectiveness of each technical solution meets the evaluation criteria, known as the absolute economic effectiveness test. Second, determining which technical solution has the best relative economic effectiveness, known as the relative economic effectiveness test. The purposes and functions of these two tests are different, and both are usually indispensable to ensure that the selected technical solution is not only feasible but also optimal. The relative economic effectiveness test can only be conducted independently when one must be chosen from among many mutually exclusive schemes. However, it should be noted that, when conducting the relative economic effectiveness test, regardless of the indicators used, the comparability conditions of the schemes must be met. Based on their service life, mutually exclusive schemes can be classified into three types: schemes with equal lifespans, schemes with unequal lifespans, and schemes with infinite lifespans. 2. Economic evaluation of mutually exclusive schemes with equal lifespans. For mutually exclusive schemes with equal lifespans, since their calculation periods are the same, they are comparable in terms of time. When evaluating their economic effectiveness, commonly used evaluation methods include net present value (NPV) method. The NPV method can be further divided into two calculation methods: the differential net present value (DELT NPV) method, and the NPV maximization criterion. Steps and criteria for evaluating mutually exclusive schemes with equal lifespans. Using the differential net present value (DELT NPV) method. Absolute economic effectiveness test. Calculate the NPV for each scheme and evaluate it. If the NPV of a scheme is greater than or equal to 0, it passes the absolute economic effectiveness test and can continue as a candidate for further selection. If the NPV of a scheme is less than 0, it is discarded. Relative economic effectiveness test. Rank the schemes that have passed. The absolute economic effectiveness test. In descending order based on their investment amounts. And calculate the delta NPV for each pair of schemes. If scheme A and B are mutually exclusive schemes with different investment amounts, and both have a lifespan of N, the cash flow of the scheme with the larger investment, scheme A, is subtracted from the cash flow of the scheme with the smaller investment, scheme B. To obtain the differential cash flow, the net present value of this differential cash flow is called the differential net present value, denoted as delta NPV AB. It reflects the investment effect of the differential net cash flow compared to the benchmark rate of return. The calculation formula is delta NPV sub A to B equals the cash flow of scheme A minus the cash flow of scheme B. Decision criterion. When using the differential net present value delta NPV to select the optimal scheme, the decision criteria are as follows. If delta NPV sub A to B is greater than 0, it indicates that the rate of return brought by the differential investment exceeds the benchmark rate of return, and the scheme with the larger investment is superior. If delta NPV sub A to B equals to 0, it indicates that the rate of return brought by the differential investment is equal to the benchmark rate of return. Based on the principle of profit maximization, the scheme with the larger investment is superior. If delta NPV sub A to B is less than 0, it indicates that the rate of return brought by the differential investment is less than the benchmark rate of return, and the scheme with the smaller investment is superior. The NPV method can also be used to evaluate the economic effectiveness of mutually exclusive schemes with equal lifespans by applying the NPV maximization criterion. Since delta NPV sub A to B equals NPV sub A minus NPV sub B, when there are multiple mutually exclusive schemes, it is more convenient to directly use the NPV maximization criterion to select the optimal scheme. This method yields consistent conclusions. With the differential NPV method, the steps and criteria for evaluating mutually exclusive schemes with equal lifespans using the NPV maximization criterion are as follows. Conduct an absolute economic effectiveness test. Calculate the NPV for each scheme and evaluate it. If the NPV of a scheme is greater than or equal to 0, it passes the absolute economic effectiveness test and can continue as a candidate for further selection. If the NPV of a scheme is less than 0, it is discarded. Conduct a relative economic effectiveness test and select the optimal scheme, which must satisfy the NPV maximization criterion. Discrimination criterion. The scheme with an NPV greater than or equal to 0, and the maximum NPV, is the optimal feasible scheme. Next, let's understand the NPV method through an example. There are 3 mutually exclusive investment schemes with a lifespan of 10 years each. The initial investments and annual net benefits for each scheme are shown in the table below. Please select the best investment scheme. I sub C equals 10%. The initial investments and annual net benefits for mutually exclusive schemes A, B, and C are as follows. Scheme A initial investment of 1.7 million yuan. Annual net benefit of 440,000 yuan. Scheme B initial investment of 2.6 million yuan. Annual net benefit of 590,000 yuan. Scheme C initial investment of 3 million yuan. Annual net benefit of 680,000 yuan. Let's first use the first method. The differential net present value (delta NPV) method. To compare and select the schemes. Solution. Conduct an absolute economic effectiveness test. By calculating the NPV for each scheme. NPV sub A equals minus 170 plus 44 multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 1.0034 million yuan. NPV sub B equals minus 260 plus 59 multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 1.0251 million yuan. NPV sub C equals minus 300 plus 68 multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 1.1781 million yuan. Since NPVA, NPVB, and NPVC are all greater than 0, schemes A, B, and C have all passed the absolute economic effectiveness test. Conduct a relative economic effectiveness test. Sort the schemes by investment amount from largest to smallest. And calculate the delta NPV between each pair of schemes. Delta NPV sub B to A equals minus 260 minus negative 170 and plus left parenthesis 59 minus 44 right parenthesis multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 21.7 thousand yuan. Since delta NPV sub B to A is greater than 0, it indicates that scheme B, which has a larger investment, is superior to scheme A, which has a smaller investment. Therefore, scheme A is eliminated. Delta NPV sub C to B equals negative 300 minus negative 260 and plus left parenthesis 68 minus 59 right parenthesis multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 153,000 yuan. Since delta NPV sub C to B is greater than 0, it indicates that scheme C, which has a larger investment, is superior to scheme B, which has a smaller investment. The order of superiority among the three schemes is: scheme C is the best, followed by scheme B, and scheme A is the worst. Therefore, the optimal scheme C is selected as the best investment scheme. Next, let's use the second method, the NPV maximization criterion, to compare and select the schemes. Solution. Conduct an absolute economic effectiveness test. By calculating the NPV for each scheme. NPV sub A equals minus 170 plus 44 multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 1.0034 million yuan. NPV sub B equals minus 260 plus 59 multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 1.0251 million yuan. NPV sub C equals minus 300 plus 68 multiplied by left parenthesis P over A 10%, 10 right parenthesis equals 1.1781 million yuan. Conduct a relative economic effectiveness test and select the optimal scheme. Since NPV sub C is greater than NPV sub B, greater than NPV sub A, scheme C is the best, followed by scheme B, and scheme A is the worst. Therefore, the optimal scheme C is selected as the best investment scheme. That's all for this video. Thank you, everyone.